So this is question number 4 of May 2023 Time Zone 1 Paper 2. We're told that a company manufactures metal tubes for bicycle frames. The diameter of the tubes are normally distributed. They're normally distributed with a mean of 32 and a standard deviation of omega. The IQR is 0.28 and we're asked to find the value of the standard deviation or the value of sigma. So as it's normally distributed, then its probability is going to look something like this. Now excuse my drawing skills. Okay, so you can imagine Q1 being here, and Q3 being here. Again, apologies, not the best representation, but I'm just going to give you I just want to give you the gist of it. So right in the middle is your Q2, which is the mean of the distribution, right? So this area right here, this is 25%, and this area is also 25%. So in total, it's 50% of the data between these two. Between Q3 and Q1. So IQR represents 50% of the data. 50% of data. Right, and now we're asked to find the value of the standard deviation. Okay, so if we were to consider 25% of the data, so from Q1 to Q2 is 25%, right? And you can calculate the z score of that 25%. As it is normally distributed, it will have we can consider the inverse normal of 25% with a mean of 0 and a standard deviation of 1. Now if I calculate that on my TI Inspire, I guess that'll take a bit of time to load. So I just entered my values on my GDC and I got a value of negative 0.674. Negative 0.674, right? So this is the z square from Q1 to Q2. Now we know z or z is simply x minus mu over the standard deviation. So you can plug in your x and your mu and your z. But what should we plug in for x? I guess you can. We have our mu is our Q2. So I guess you can simply do Q2 minus 0.14, right? Because, or let's say minus 0.28 divided by 2. This is the interquartile range divided by 2. And this will equal to Q1. So Q1 is equal to 32 minus 0.14, which will equal to 31.86. Right, so your standard deviation will be 31.86 minus 32 divided by negative 0.674. That'll equal to a value of 0.208 for your standard deviation. I'd like to add, perhaps you're wondering why we use the inverse normal of 25% with 0 and 1. Well, any distribution that is normally distributed, it can be the z square of that can be calculated using this equation right here, right? And so this z square, right, that was calculated to the inverse normal with an area of 25%, a mean of 0, and a standard deviation of 1. This right here is equal to the z square calculated through the formula x minus mu over sigma. So you can use this in essence to, I don't know, either find mu, the standard deviation, or x. So it's more or less standardized.